Okay, okay. This probably needs a little bit of explaining. You just saw me make this quick drawing of the actual finished part. And I made some design changes. If you look at the original part here. The most obvious is of course this sharp corner here. That's just a really, really bad design. I also made the center part a lot thicker because we had the opportunity to do that. And this hexagonal shaft here is not needed, so I'm going to make that round also. And from that finished part, I have to figure out how to forge a rough shape. And basically I have made this forging drawing here, and I've more or less just added a couple of millimeters all around so I can machine it to size afterwards. And when you have this forging sketch, you can calculate the starting stock. And I get a lot of questions about that, how you calculate how much material you need. And that is simply done by calculating volumes. So I've calculated the volume for each section here. And then from the volume I can calculate backwards to see the length I need for a given starting stock. So numbers are here, and a total length is 140 millimeters. And those numbers also give me the position of the set downs I need to forge. So I can mark those out on the blank and go from there. I hope I've made this right. Let's see. Let's see what we have in this little pile here. Mm-hmm. 140. Perfect. Okay, I know many of you are scratching your heads and are thinking, why am I going through all this trouble with forging this part? I could have just turned it on the lathe to start with, right? Well, this part has a pretty demanding application. I know you don't know what it is yet. I don't blame you. But strength is good in this application, so that's why. Most of us think of steel as a homogeneous mass only, but that's not the case really. It has a crystalline structure that we call grain. And in a piece of bar stock like this, the grain flows with the bar. Almost like grain of wood. And if you would turn this down, you would just cut the grain off. And that is not ideal when it comes to strength. Instead, we forge the part, and by forging, we just push the material and the grain flows with the shape. So in this case, the grain flows like this. And that is much better when it comes to strength. Yeah, that's the short and simple answer. It also saves a lot of material if that's an issue. Probably not today, but still. But the main thing, it's much more fun to forge than turning ships on the lathe. So that's what I do. Oh, it's time for the kiln again after this normalizing cycle. Ta-da! Boiled linseed oil. It just gives a light rust protection. So, there we have it. Lite där. Just det, det är så de ser ut, ja. Ska vi se om det passar? Ja! Ja. Då ser vi fast den så. Ja. Jajamän. Ja. Mm.